So we are looking at geometric sequences here, and geometric sequences are sequences that increase by multiplication. Okay, so unlike arithmetic sequences, for example, increase by addition. Right? So we go 5, 10, 15, 20. These are arithmetic sequences because we are increasing this sequence by addition or subtraction. So this is arithmetic. So these are ones that we did in grade 10. These ones are geometric. So we're going to increase the sequence by multiplication. So here we're going to go times 3, times 3, times 3, etc. Okay, and we keep on going until we get to the term that we want. So for example here, if I were to find the 20th term, here's my first term. I need to times 3 once to get to the second term, twice to get to the third, 3 times to get to the fourth, 4 times to get to the fifth. So if I were to find the 20th term, I'd start at 5, and I need to times by 20 19 times, okay, because there's 19 steps between 1 and 20. And that's going to give us a super big number. Okay, so we're going to end up with quite a large number here. And it's going to be, wow, it's going to be huge. It is 581130735. And you can appreciate this, that it's going to be this really huge number because this is a geometric sequence or exponential growth. So if we let something grow exponentially times 3 times 3, it will grow very quickly, very fast. Okay, so this is a geometric growth follows an exponential equation. So if we take a look at our geometric sequence here, so here's our table for that same sequence. This is what our formula looks like, and notice that it is an exponential growth formula. There's our starting term, there's our growth factor, what we multiply or what we call our common ratio, and there's the number of times we multiply. Okay, and that's the term value. And the -1 is there because remember that we start counting from 1. Okay, so normally if we're measuring time, we start counting from 0. So there wouldn't be that -1 in, for example, a geometric growth formula. But since the sequence is we start counting from 1, if we're counting from 1, we're always 1 behind when we count the number of times we use the multiplier. So from 1 to 20, there's 19 terms. From 23 to 32, you have to subtract. Okay, so there would be 9 terms in between. Okay, so in general, the number of terms, the number of steps, is going to be the last number minus the first number. So I'll just say it's A minus B. Okay, or maybe I'll show right. N final minus N initial. Okay, and the formula has a -1 because our N initial is generally going to be 1. Okay, we start counting from 1. So this is a very useful thing to know because some people get messed up with the number of steps in between and not quite sure about that N-1. But there it is. There is our exponential growth formula. Okay, so this is a geometric sequence formula. And we're going to use this formula and identify the parts of it. There is the end amount, there's the starting amount, or which we call Tn or A. Okay, this is called T1 or our A value, our common base or common ratio. Okay, and then the exponent has the term number, or this is really the number of steps. Okay, so n is a term number, and -1 represents the number of steps to get to that term number. Okay, so we could do this one here. So we're starting with our first term is 4. We want to find out our common ratio here. So we want to know, how does this grow? How does this progress? So from here to here, we're going to do it times 5. So if I know where it starts, or I know some position, and I know how it progresses, I essentially know all the parts of this relationship. Okay, so we know we're going to go times 5. So I can figure out any part of this sequence by just continuing on this pattern. I want to use my growth formula here, so we can calculate this growth. So this is our Tn. We're starting with 4. Our growth factor, our common ratio is 5. Okay, and it's going to be n minus 1. Okay, so one way to find the growth factors, if we want to find this multiplier, we divide these numbers. Okay, so we can divide consecutive numbers to get the r value, or our multiplier. So there's our equation. I want to find the 31st sequence, the 31st term in the sequence. That means I have 30 steps from 1 to 31. Okay, so this is, maybe I'll just write this with the formula. 1 minus 31 minus 1. Okay, so that's going to be to power 30. This is going to be a really, really big equation, a big number. I don't think it actually asks you to calculate it, but this number is going to be really, really big. Okay, so if I work out this number, it doesn't even fit, the digits don't even fit on my calculator. This is 3.72 approximately times 10 to the 21. So there's 21 digits to this number. Okay,